We'll see. So sorry about last time when it froze up on you guys. Yeah. Okay. So basically what they were doing in teaching adding was they were getting kids to be good at having two numbers added together to give you 10. And so they would, for example, this 35 plus 8, normally you might write 35 down and you put 8 underneath. So this would be the way we might have remembered how to do it, 35 plus 8, and then we draw a line and we'd say, okay, 8 plus 5 is 13, so I write a 3 down there and I carry the 1, and then the 1 plus 3 is 4, and there's my answer. Okay. So what they're doing is they're saying, let's think about what number do I have to add to 5 to get to my next friendly number, they called it. And the friendly numbers are 10, 20, 30, 40, so they're decade numbers. So you would know that 5 plus 5 is 10. So what you would do basically is you would say, well, I need to take 5 from 8. 5, so I break 8 up into 5 and 3, and I group these two together. So I add these two numbers together to get my friendly number, and then I add 3 on the end of it, which is easy because all you do is you just add that to 0, which everybody can do that, and you get 43. So you basically, instead of having to have this thing where you're adding 8 plus 5 to get something more than 10, then carrying it, so it is reasonably complicated if you think about it. You do it for a long time. A lot of times it seems simple, but in some ways it would be easier to do it this way, where you're remembering 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10, so forth and so on. So that was kind of the idea. And they also did this thing where they they took 30 things, 30 leprechauns, I guess, and they wanted them to decide how many traps they had to buy, and each trap had to have the same number of leprechauns in each trap. So they had those little manipulative things where they could move them around and group them into, they could see that they were the same height and therefore they were the same value. And you could play around with that and come up with a lot of different combinations. I mean, you could have groups of 2, and you'd find out there are 15 of those, 15 of the 2 group blocks. You could put them into groups of 3, and you'd find out there are 10 of those. So what they were saying was we weren't doing multiplication or division, we were actually adding. So you might have noticed when they did this one, what they did was they were able to count by multiples of a number. So that is another skill that they teach them, to do multiples of a number. So you can go, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, so forth and so on, that kind of thing. So they were treating multiplication and division as an addition problem. And once you got good at that, when you introduce multiplication, you might understand it a little better instead of just memorizing the multiplication table. I mean, ultimately you have to memorize something, but sometimes it's appropriate to be able to do that kind of stuff, and sometimes some kids get it and some kids don't. So, okay, so that was what they were doing in this one. The next one is subtraction, and so for you guys online, this video, let's see how long the video is. Next Wednesday, last day of class. So it's a 13-minute video. So let's watch this. So you guys online, click on the link, come back in 13 minutes, and we'll talk about the video. So I'm gonna stop the recording for right now. So go ahead and watch this travel teaching channel thing later, because I'm going to talk about some of the techniques that they discussed in the video. So let's go back to here. So what they were doing was they were looking at different ways of doing subtraction. They talked about the traditional way, which is probably what most of you remember. I'm not sure how they taught you as far as subtraction, but so I'm going to explain 2 of the other techniques that they learned. So I'm just going to make up a subtraction problem. 472 minus 163. Okay, so what's the answer? Well, one way of doing it was to use the number line, and you start with the lower number. And basically you switch it into an addition problem. And you break it up into multiple steps where you ask the question, what do I need to add to my original number to get to the next higher decade? So if you're starting in the ones, you want to get to the tens. So the first thing I would do is want to get to 170, which is the next higher decade number. And the difference between those would be 7. So you write that down. Then I'm trying to get to 472, and I see I've got 170, so I can actually just skip over the tens at this point, and I could say, well, to get to 470, I need to add 300, and then to go the remaining 2, I would add 2. So that's 300. So the answer would be 309. You can add those. So you recast a subtraction problem as an addition problem. And of course, if we did it the standard way, what we would have to do is, in this case, you have to think, oh, I've got to change the 2 into a 12. I've got to borrow 1 from this column. So this becomes 12. 12 minus 3 is 9. 6 minus 6 is 0. And 4 minus 3 is 3, or 4 minus 1 is 3. So you get the same answer. But this is a way that you could probably do it in your head more easily than you could trying to go the other direction. So what you might do in your head is think, okay, I've got 7, so I keep kind of 7 in my mind to get to 170. Then I got 300, so I got 307, and then I go another 2 to get to 472, and so I've got 7 plus 307 plus 2 is 309. Okay. So that's one way of doing this kind of problem. So why don't you guys try it? So let's say 721. Well, I'll do one more and then we'll let you do it. So 193. So again, what I would do is I'd start at 193, and I want to get to the next decade, which would be 200. Or actually the next 10, but it turns out in this case by adding 7 I get to 200. Then I need to go all the way to 700, so then I do it by hundreds. So I go to 700, that would be 500, and I could then do 20. You might just say, why don't I just do 21? And I'll explain that in a second. So you need 20 more to get to 720, and then 1 more to get to 721. So then I could add the hundreds together, and then I could add the tens together, and add the ones together. So I'd have 520, and 1 plus 7 is 8. So you would get 528 by adding these numbers together. And that's a lot of times is what you see on Facebook. They show this crazy thing where they're doing, they're going like this, like that, and it looks much more confusing, and it may take more steps, but in reality, it's not meant to be. It's just to be able to do the So let's give you let's do this one. So let's do 524 minus 267. So try that one out. So if you guys online, don't use your calculator. That's cheating. So you're going to start at 267. And then see if you can figure out what steps you would make to get. So you get 257. Now you might say, well, could I have gone 270, 370, 470? The answer is yes. Then you go from 470 to maybe 500, and then 500 to 520, and then 520 to 524. So that would be another option. So let's just show you that way. It's up to you. As the video was talking about, it's really just what the students find the easiest way to think about it. So I could do that, and I could go up to, I wouldn't go up to 570 because that's greater than my number. So I'd go to 470, then I'd probably go to 500, and then I would go to 524, and then actually 520, and then 524. So I'd have 3, 200, 30, 20, and 4, I guess. So you'd have 257. 200 plus these two added together would be 50. These two added together would be 7. You get 257. Okay, so that was one way of doing it. Let's do the same numbers, but use this other subtraction technique. So how many people have ever used that before? Okay. The other way of doing it was dealing with negative numbers. So what you do is you subtract 3 from 2, which is going to give you a -1. And you can kind of, you can almost use your fingers to do that if you wanted to do. You start with 3, you take away, well, you start with 2, and you take away 3, you'd have 3, 2, 1, 0, and then you'd have -1. Then we'd have 70 minus 60, or you can just think of 7 minus 6 and keep it in this column. So you'd have 70 minus 60 would be 10, and 400 minus 100 would be 300. And then you add the positive numbers together, which you get 310, and you'd subtract 1, which would be 309. Let's do another one. So 721 minus 193, 1 minus 3 would be -2. 2 minus 9 would be, or 20 minus 90, which would be the same as 2 minus 9, which would be -7. Because you can think about it the other way, it's 9 minus 2 and then make it negative if you're having a hard time. So the same way here, if you just want to subtract positive numbers, you could take 3 minus 1 and make the sign opposite. You can do the same thing here. If you can't remember how to subtract 9 from 2, you could subtract 2 from 9 and then change the sign. So 9 minus 2 is 7, but because this one's on top, it would be -70. And then you have 700 minus 100, which would be 600. And then when you go the other direction, you'd have 600 minus 70, which would be 630, and then you'd subtract 2, which would be 628. And I did it wrong, because it's 500. 600 minus 70 is 530. I did it wrong. 530 minus 2 is 528. And we'll do one more, and I'll give you one to do. So it's 524 minus 267. 4 minus 7, or 7 minus 4 minus, so that'd be -3. 2 minus 6 is going to be equal to, and the way I'm thinking about it, the way you would do it, if you're not good at it, you'd say, okay, to get to 0, I need 2 units. So I'm going to use 2 of those to get to 0. I'm going to subtract 2, and then I'm going to subtract 4 more to get the total amount. So that'd be -40. And 5 minus 3 is equal, 5 minus 2 is 3, but it's positive, so it's positive 300. And so then you finally do the final calculation. 300 minus 40 is going to be 260. 260 minus 3 is 257, which I think is the right answer. Okay, so once you let me give you another example here. So 621 minus 257. Question. I think, from a teaching in the traditional way, I think this is an easier way to understand it, kind of as a stepping stone from what you've already learned. Yeah, it might be easier for us. It's different, so we don't like it. I know. Yeah. So when your kids come home, don't immediately say, it's not the way I used to do it back in the old days when I lived in a paper cup in the middle of the road and had to walk uphill both ways to school. When you get old and you do those kinds of things. What's that? Yeah, both uphill both ways. Yeah. Yeah, that's physically impossible. Okay, so 1 minus 7 is negative 6. 2 minus 5 is negative 3, so it's going to be negative 30. And 6 minus 3 is 3, so that's positive 300. So 300 minus 30 is 270. 270 minus 6 is 264. Is that the right answer? Huh? I don't know. I was looking for videos about stuff, and I saw this one. I thought, that's cool. I never saw that. I don't know how they're actually teaching it, but yeah, you carry and the traditional way. Yeah. Oh, what, the borrowing stuff? Yeah, it is bad. It is. The traditional way is not good for mental math, and that. You're still what now? Yeah, that's probably part of the reason is we don't teach the skills for doing mental math. So we rely we rely on a calculator, and secondly is using the traditional methods are not meant to be able to do these kind of things.
Have you ever noticed in some of your countries them say 1,000?
1,000? Yeah, it's a regional dialect where they do the TH as an F sound. And where my family's from, I don't think they do that. Thousands. Yeah. Yeah, they're... That was an interesting. So I'm listening to my BBC radio station, and in England they don't have Thanksgiving, but of course they have Christmas, and so a couple of years ago the businesses tried to get the equivalent of Black Friday happening over there to spur sales. But there's no holiday after. It's just a Friday that's in the end of November. So there's no significance to it except it's Friday. And it's interesting. There's kind of a backlash to the whole thing, because of the same reason Black Friday is a backlash here, because it becomes too commercialized and people do stupid stuff to save money, like dangerous, So there was the radio presenter said that she went out shopping Friday afternoon, and she said it looked like a normal day to her. So maybe people are getting the message that this Black Friday, and of course they say, yeah, it's one of those things that we've imported from America, like with very facetious or mocking tone, but
yeah, they use that term, but they've imported a lot in our culture.
Yeah, they try to resist it. They are called, and one other thing is when I was growing up, in my family, and I'm assuming we lived in America for most of the time, but they would always say Father Christmas. That was, Santa was an American thing. But now I'm noticing that they do say Santa a lot more. Father Christmas, yeah. We used to put a pillowcase on actually on their bed. So that was like your stocking, but it was just an empty pillowcase. That was one of the traditions. And I hated Christmas food. They have this thing called Christmas pudding. Anybody ever heard of Christmas pudding? It's very, very dense. It's got a lot of raisins, and I don't even know what's in that stuff. I hated that. Oh, and then they also another thing my mother always made was mince pie. That's awful too. We were never big into blood sausages. I mean, my dad liked it, and when he went over to England, he would eat it. But we never really lived on blood. We usually had roast beef or roast lamb or something like that for Christmas dinner. The other thing I hated and is Brussels sprouts. So how many people here like Brussels sprouts? I know it's this dichotomy. People either love Brussels sprouts or they hate it. So there were maybe 3 things that I couldn't stand. I had to eat them. My dad would make me eat them. You need to eat those. Okay, so I'd get my Brussels sprout and I'd hold my nose and I'd eat it and then drink something as quick as possible. Yeah. Okay. I think I signed the homework, didn't I, last time or not? Okay, so there it is. Well, this is what do we talk about? We just talked about types of numbers, number lines, additive inverses, those kinds of things. It's not really. There's not a whole lot. There's a lot of problems, but they're not that hard. How many more? Actually, there's 4 sections still, 4 or 5 sections still left. I'm not sure if. Yeah, I know. I don't know. Because I give you a whole. I mean, I'm a nice guy. Usually, I give you a whole week. So now I'm going to cut it down to 2 days. Whatever I assign Tuesday is the last assignment. Oh, I got to plug my computer in. Yeah, yeah, it is. Another thing I remember about Christmas is my granddad. He used to send us my Christmas present, our Christmas presents. Well, I guess it was for all 3 of. We have 2 brothers. He would send a package with a kind of English candy called Crunchies, and what they are is they're a honeycomb body with chocolate on the outside. So the honeycomb is kind of really sweet. Pardon me? No, it's basically sugar, just pure sugar. And so he would send a box of, I don't know if it was 24 or 50 or something like that. That was our Christmas present. And so we would separate them up. Each of them would get the same amount, so maybe 24, I don't know. And then we would guard them with our life. We would hide them and, don't you eat my Crunchies. And then we would ration them to make them last as long as possible, because that was used to be. Well, now it's more easily done than it used to be, but back then it wasn't something you could get that easily. They are good. You would like them. You can get them. You can buy them in New York City when we go visit. Okay. Now this is again with a word of warning. Again, these are things that you have already learned, but again, try to have an open mind about what I'm going to explain to you. Again, think if you're teaching kids about this. Okay, so all we're going to do is talk about adding, subtracting. Actually, I don't even know if we talk about multiplying, but so there's two cases here. One is adding 2 numbers together that are both positive or have the same sign. So they could be both positive and they could be both negative. And then there's a rule where one is positive and one is negative. And as I mentioned last time, what we're really doing, instead of subtracting, we're treating subtracting as adding the additive inverse of a number. So you're adding a negative number, which is the same as subtracting. So when it says unlike signs, so let's just read. It says if you have like signs, meaning they're both positive or both negative, you add the numbers with the same sign by adding their absolute values, which I didn't talk about, so I need to go back and talk about that. The sign of the sum, either positive or negative, is the same as the sign of the two numbers. So let me go back and talk about absolute value. Skipped over that. So what do you guys remember about absolute value? What does an absolute value mean? Pardon me? Yeah. So no matter if it's positive, it's positive. If it's negative, it's positive. Yeah. So that's kind of how we remember it. Pardon me? That's probably a good way to do it. The way they define it in the book here is they say for any real number, the absolute value of x is defined as follows. The absolute value of x equals x if x is greater than 0, which means it's positive. The absolute value of x is equal to negative, which means the additive inverse of the value if x is less than 0. So what this means is if x is less than 0, you change the sign from negative to positive. So it just means any number, whatever sign it is, you make it positive, like Mackenzie said. So here's my two examples. If x is 3, which is positive, which is greater than 0, then the absolute value of x is just the value. So the absolute value is 3. If x is less than 0, which is the second case, then you take x and you take the additive inverse of negative 4, which turns out to be positive 4. So it's equivalent to always making the number positive. The actual formal definition is if you have a negative number, you take the additive inverse of that number, which results in the positive number, but that's the official definition. Okay. So we'll go back to section 2 again, and we'll see. So let's just do an example using these rules. And it's not as stupid as it seems, because people have a hard time when you ask them to subtract a number larger than the original number. You end up with a negative, or if you subtract a negative from a negative, you can think about it on the number line. That's one way of doing it, or you can use these rules. So we'll do both ways. So we'll do the 4 different possible cases. You've got, let's say, 13 plus 4 equals. So what they're saying is you take the absolute value of both numbers. So the absolute value 13 is 13, and the absolute value 4 is 4. And then you add the numbers together, you get 17. And it says that the result is the same sign as the sign of the original two numbers. So since the original two numbers were positive, that means that the final result is positive 17. So again, you take the two numbers, take the absolute value, which is that. You add the absolute values together, and then you look back at the original addition problem. So if we did it, let's do two negative numbers. So let's see, you have negative 11 plus negative 17. So they're both negative. So what you do is you take the absolute value of negative 11 plus the absolute value of negative 17. So the absolute value of negative 11 is positive 11, and the absolute value of negative 17 is positive 17. So you add those two numbers together, which are both positive. So you can think of, it's easier to think of it if you're counting fingers. So Harley's good. So this is, you're going to count, you can't count negative. Yeah, my younger daughter does the same thing. So you add these two, you get 28. And so going back to the original problem, it says when you add two negative numbers together, the answer is 28, but you keep it the same sign as the original two numbers that had the same sign. So if you add two negative numbers, the answer is negative. If you add two positive numbers, the answer is positive. So this one's trivial because all I did was, this is the same as that. When you have two negative numbers, then I think it's raining, yeah. Yeah, I do hear that. Oh, look at this. I have new ear pads. Yeah, I know. I've had these for about 4 years, and they were starting to wear holes in them, so I went to Amazon and bought my new pads. That's my Christmas present to myself. Yeah, I bought them before then. Okay, so that's the first rule applied to two negative numbers. So let's look at the second. So what it says is to add two numbers with different signs, you subtract the lesser absolute value from the greater absolute value. So let's say we have 12 minus or plus negative 7, which is the same as 12 minus 7. But I'm changing everything to addition problem. Subtraction is an addition problem. Orange is the new black or something like that. So what it says, to do this, it says, let's do the absolute value of each one of these. The absolute value of 12 is 12. The absolute value of negative 7 is positive 7. So we usually can order positive numbers easily. So now they're both positive. And so since 7 or 12 is greater than 7, what we do is we subtract the smaller absolute value from the larger absolute value, and you would get 5. Okay, so subtract the lesser absolute value from the greater absolute value. Then it says the sum is positive if the positive number has the greater absolute value. So we go down here. The positive number, which is 12, has the greater absolute value. So since the positive, I guess it's the absolute value of the positive number, I should really say. So since the absolute value of the positive number is greater than the absolute value of the negative number, then the answer is the positive of this subtraction. So it's positive 5. We already, again, it seems like a long way to go, and it really, but if I gave you this problem negative 7 plus 12, which is not in the traditional format, where you're, in this case, I'm not the initial problem doesn't look like a subtraction problem anymore because I have the negative number for the positive number. Now, if you knew the properties, some of the properties of arithmetic, we know that we could change the order and then it looks like a subtraction problem. But if we didn't know that, we could still use the same procedure. We take the absolute value of this, the absolute value of that. We subtract the smaller absolute value from the larger absolute value, and since the larger absolute value is positive, we get the same answer. So this procedure would help you when you have a situation that doesn't look initially like a traditional subtraction problem. Okay, the final one is is if I have this arrangement. So if I had, let's say, negative 31 plus 17. So what is the answer there? So there are different signs, so we use the second procedure. Unlike signs, the procedure says you take the absolute value of both terms, and then you subtract the smaller absolute value from the larger absolute value, which is 14. And then it says if the greater absolute value is negative, originally a negative number, then the answer is negative. So that means that my original problem, negative 31 plus 17, is not going to be 14, but it's going to be negative 14 because the absolute value of the negative number is larger than the absolute value of the smaller number. So those are the 4 cases on how you apply the rules. And for some of them it seems trivial, but for some that maybe you've struggled with in the past, it's a way of and again, it ultimately comes down when we actually subtract something here, we are subtracting something bigger positive from something smaller positive, which you can imagine things being taken away, but when you have negative numbers, taking away negative numbers from negative stuff, you can't visualize that, and that's why I think they do that. So I found that interesting. And by definition, in math, we instead of using subtraction, what we're doing is using we're adding a negative number. So that kind of comes down to the number line version of the whole thing. So if I wanted to do this problem number line wise, how would I do that? So I would draw a number line, and I'd locate 0 somewhere, and I'm going to use marks 10 units wide. So this would be 10, 20, 30, negative 10. Actually, I don't need these, but let me just, well, actually I do. So there's 2 ways you can do this. You can do it in either order. So I could start with negative 31, which would be here, and then I add 17. So anytime you add something, you move to the right on the number line. So I would move 17 units this direction because I'm adding the number. So I know that the number would be greater than, more positive than negative 31. So it would end up being negative 14. Or you could start at 17. So you could go the other way. You could start at 17 and go negative 31 units in the other direction. And in both cases, you'd end up with the same final point on the number line, which would be negative 14. Okay, so that's kind of the subtraction thing. Oh yeah, okay, so here's multiplying real numbers. So we are going to talk about multiplying. And again, just like you can treat subtraction as adding a negative number, you can treat division like dividing or multiplying by the reciprocal of a number. So again, we've got this case, if you multiply 2 numbers that have the same sign, what's the answer? If you have different signs, what's the rule that we learned in math in terms of signs? Well, how would you verbalize that? If you multiply 2 positive numbers, you get a positive. If you multiply 2 negative numbers, you get positive. If you multiply a negative times a positive, you get negative. Yeah, okay, so that's the rule that we kind of remember. This is the same kind of thing. It says that if you multiply 2 numbers with the same sign, what you do is you actually multiply their absolute values together. And what's the point in doing this? So let's read it and explain why it makes any sense. So again, there's four cases. There's multiplying 2 positive numbers together. So what they're saying is you take the absolute value of each one of these, and the absolute value of 3 is 3, and the absolute value of 7 is 7, and you multiply them together and you get 21, and it says the product is positive. So you take this number and you say it's positive. So that's the answer. Okay. Again, that's somewhat trivial. If we take two negative numbers and multiply those together, what's the answer there? Well, what they say is take the absolute value of -4 multiplied by the absolute value of -7, and the absolute value of +4 is, -4 is +4, and the absolute value of -7 is +7. You multiply those together, you get 28. And because they have like signs, because they're both negative, the answer to the original multiplication problem is +28. So why do you think why do they go to that extra trouble of taking the absolute values? Again, it kind of comes down to if you're using those little manipulative blocks to represent multiplication. You're dealing with positive quantities of blocks, and you're evolving positive groupings, number of multiple groupings of those blocks. Or you can think of multiplication as just adding the same number together so many times. So 3 times 6, you take 6, and you take 6 and another 6 and another 6 and put them together, and that total is going to give you 3 times 6. And so, again, you're looking at concrete, real things. If you're taking -3 something, there is no such thing as -3 soda, Hardee's glasses. So what they're doing is they're making the actual multiplication problem involving positive things. And then once you get the result, then you can make some conclusion about the sign of the result after you've done the multiplication. So our other two cases are, if the first number is negative and the second number is positive. So if we do 2 times -3, so they say take the absolute value of each number, which makes them positive. So now it really makes sense as far as visualizing it. 2 times 3 is 6, but because the signs of the two original numbers are different, the answer of 2 times -3 is not +6, but it's going to be -6. And if the order is changed, the negatives first and the positive second, you still got the same results. I'm not going to repeat that. So I think that's the reason they do that. Because again, if you're teaching kids about multiplication and addition and division, all that kind of stuff, it's good to visualize real things, not negative things. And actually, in this case, they don't change multiplication division into multiplication of the reciprocal. It's the same kind of rules. You do the division with positive numbers, and then you decide on the sign of the result based on if they're both positive, the result's positive. If they're both negative, the result's positive. If the signs are different between the numerator and the denominator, then the answer is negative. So we won't give you an example on that. And the one thing we haven't talked about is dividing by 0. Anytime you divide a number by 0, it's undefined. Now what's the other thing you may say? If you took, let me just get a number here. If I said you had 2 divided by 0, they're saying it's undefined. What might be another response that somebody would put that you might have seen in the past? 0 or this thing, that thing. So sometimes some people might do this, which stands for infinity. So why wouldn't they say that it equals infinity. Because ultimately what you're doing is, you can think of it, 2 divided by 0 is approximately equal to 2 divided by a very small number. Okay, so 2 divided by this number would be I guess 2 million, which is a big number, right? And so as this number, as the denominator gets closer and closer to 0, this number becomes larger, 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 larger. So when it goes to 0, when it equals 0, you might say it's equal to infinity. Okay, so let me shut up and see if anybody answers. So why might I not say it's equal to infinity? I have no idea. Okay, that's fine. Most people don't. That's why I'm bringing it up.
2 divided by 0 and 3 divided by 0 are different. You wouldn't want to say that they're both equal to infinity.
Well, you may think that. That would be a thought about that. But the reason is because nothing equals infinity. Because infinity is not a number, it's a concept almost. It's because if you said, I'm going to go to infinity, there would always be further that you could go. So you can never get to infinity. Therefore, you can never equal infinity. And therefore, you say that a number divided by 0 is undefined instead of doing that. So that's the reason. So just remember that. Infinity does not exist. So there's one other case. What if you had 0 divided by 0? Is that equal to 1? Question mark. Because it's the same thing, right? If you had 1 divided by 1, that would be equal 1. 2 divided by 2 equals 1. A divided by A is equal to 1. So it seems like 0 divided by 0 would be equal to 1. Does anybody know what that's called when you have 0 divided by 0? It's not infinity. It says it's indeterminate, which is kind of like, it doesn't mean that it doesn't exist like a number divided by 0. It just means that you don't know what it is. Because you could have, if you ever take calculus, you would find out that 0 divided by 0 can be any number. It can be 0, it can be 5, it can even be infinity. It all depends on how you end up with that. So it's called indeterminate. They don't mention this in the book, but so division by 0 is undefined except when the numerator is 0. If you have a non-zero term in the numerator, then dividing by 0 is undefined. Okay, so that's kind of a complicated way of doing subtraction, addition, division. But if you follow the rules, you won't make any mistakes as far as doing those subtracting, adding negative numbers, or adding negative and positive numbers. Then we have order of operations, which sounds simple, and you're like, oh yeah, I know how to do that, but I always give a test problem, and it's amazing how many people don't get it right. So people don't know it as well as they think they do. And there's that, does anybody remember the thing to remember order of operations, or some word, made up word? PEMDAS, yeah. Who said that? Oh, good. So let's write it down, see if you guys remember what PEMDAS stands for. Okay, P, parentheses, E, exponents, M, what's that? Multiply. So that's what PEMDAS says. So it says work separately above or below any fraction bar. So that actually doesn't come in PEMDAS, but it's if you have a fraction bar. So what is a fraction bar? If you had like x plus 2 divided by x minus 1, that's the fraction bar. I mean, normally we think of it maybe in terms of a fraction, 3/6. That's the fraction bar. But it's the horizontal bar that says I'm going to divide this by that, whether it's numbers or whether it's variables. So you do all the operations in the numerator and the denominator first. And then it says use the rules below within each set of parentheses. So that's the parenthesis part. Or square brackets. You start with the innermost set and work your way outward. So that's the P part. Then it says if no parentheses or brackets are present, so you do these within the parentheses. Once you've completed, simplified what's in the parentheses to a single term, then you can apply it to the rest of the problem. So you do exponents, then you do multiplication or division. So you don't have to, it doesn't really have to be PEMDAS, it could be PEDMAS or whatever it is. So these are either way. And then finally, do any additions and subtractions in the order in which they occur, working from left to right. So in both cases from left to right. So let's just look at let me make up a problem. We'll start easy and go from there. So let's say you have 2 plus 3 divided by 1 plus 5. So the first thing it says is you do everything that's in the numerator and everything that's denominator. So you would add these two numbers together. And you would add these two numbers together. And at this point, you may not even do the division. You might just leave it as a fraction. Okay, so let's think of what's next. They said parentheses next. Okay, so let's say you have 2 times 1 plus 5 divided by. So in this case, if you would normally, at this point, you would put it in its simplest form as a fraction. So this is the simplest form because there's no common factor between the numerator and the denominator. So this would be done, would be finished. But I'm going to do one here where you can simplify it. So in terms of the numerator, I have to do everything in the numerator first. So I do the first operation within the parentheses. So 1 plus 5 is 6. And I divide by 4. Okay, so that's the first thing. So I've done everything that's in the parentheses. I've reduced what's in the parentheses to a single number. Then what's next? I don't have any exponents, so I go ahead and multiply. But I multiply within the numerator. So I get 12 divided by 4. Now I've got single numbers in the numerator and the denominator, so then I can divide. And because I can simplify this, I would go ahead and do it. And so I would end up with 3. So that's. Now if you have more than one set of parentheses, let's say you have 5 times 1 plus 2 times 4 divided by 3. So when you have multiple sets of parentheses or parentheses and brackets, you always start from the inside. And I think what people get confused about here is they try to do too many steps at once. And you should just do one, unless you're really good at this, you should just do one type of operation at a time. If it's on a test, you're going to have plenty of time. So it's not like you're going to run out of time. You don't have to rush. So what I would do is I'd say, what is the operation within the innermost parentheses? So I do that. So 2 times 4 is 8. So by doing that multiplication and resulting in one number, I can remove the parentheses. Once you have one number, you can remove the parentheses. Then I still have a set of parentheses. I've lost one set, but I have the next set. So I have 5 times 1 plus 8, which is 9. again, I've got a single number, so I could just remove the parentheses at that point. And then I'm going to complete the, now you could say I could simplify 9 divided by 3, which is true, because it's all just multiplication and division, but let's just stick with the rules for right now. So you'd multiply the numerator out, and finally you would divide. If you can simplify it, you would do so. So you get to that point. But remember, just do one step at a time. That's the key thing. What time is it here? So let's save this. I want to show you one thing before we finish for today. And I actually don't think I'm going to get all the way through chapter 6 because I'm spending more time on some things that may seem to some people trivial, but there's enough people who get it wrong that I'm trying to give you a better chance of doing it. But anyway, let me find something here. I just want to. Let's see. So the reason I'm showing you this is, we're taking math for the liberal arts, but I want to emphasize the thing about breaking a problem down into smaller parts and taking the time to do it instead of trying to do them. All math problems don't take 2 seconds. And so this is an example of a calculus problem that I have. And it's actually a reasonably short one. But, if you take calculus, you end up having problems that may take you 10 or 15 minutes to do. And if you looked at it and tried to solve it, there's no way that you can solve it in one step. You have to break it down to individual steps. Sometimes you can skip steps that are, but most of the time you can't skip steps or you're not going to get it. So I just wanted to point out that, high-level math is just like math in here. Sometimes you just have to stick with it. And so actually, I'm going to officially sign the homework from this section, even though I haven't completed it yet, because we need to not get too far behind. So let me show you the homework for section 2. I think we're almost at the end of the section anyway. Yeah. So yeah, there's a lot of problems, but they're short. I mean, they're addition and subtraction problems. So. Yeah. No. After you graduate from college, it's flash. Yeah, no, this is. It's kind of worrying, You're not at this point in your life, but you've got less time ahead of you than you have behind you. So I'm thinking, okay, I'm 58. So let's say I live to be 80, which would be pretty good. 58, that's 22 years. So I go back 22 years, 58, 36. 36 was 19. My daughters were in high school or something. It doesn't seem that long ago, so you know, I'm thinking, oh, this. I'm a grandpa. That's right. What's that? Well, you never know. Yeah, you would hope so, but could be some heart trouble in there. You can't see.